those of you tackling titration equations at A level, and if you've done triple science, you'd have tackled titrations before at GCSE. Now I'm going to walk with you through how it gets more difficult at A level. So the ways they make the titration question more difficult are as follows. First of all, at GCSE, often in the equation, you're given an equation with 1 mole reacting with 1 mole. So the mole ratio is always 1 to 1. You're going to see that change at A level. They're going to give you 1 to 2 or 1 to 3. So you need to be able to handle that. Secondly, at GCSE, they're always expecting you to work out an unknown concentration, usually of acid or alkaline. Whereas at A level, they might ask you to express the answer in grams, or they might ask you to express the answer in number of moles. The third thing they do is they tend to make the question longer by giving you a standard solution of 250 centimetres cubed and asking you to take 25 centimetres from that. And that adds another layer of complexity to the question. And also, they often give you 2 equations to work with and not 1. Finally, just the sheer weight of information they tend to give you in the question tends to be quite intimidating first time you come across it. So I'm going to show you a way to work through that large amount of information in quite a short period of time to try and come up with the answer that you're looking for. So let's look at the first question. What a joy it is. So you might want to pause this and see if you can work it out yourself first. I'm just gonna read it out. What a lot of information there, designed to confuse. So I'm going to try and show you some strategies to get through that kind of information really, really quickly. But I am going to have to read it out. Iodine is needed in small amounts in our diet. Iodine deficiency can lead to impaired physical and mental development. Waffle. Don't worry about that one. Common salt can be iodized. I've never taught anyone about iodizing of common salt. So again, just a bit of background to scare you. By the addition of potassium iodate. It's just completely evil. KiO3. I do know the formula for common salt, that's NaCl, so maybe the K and the Na would swap over. That might mean it's NaIO3 minus O3. A student decides to determine the amount of iodate ion, IO3 minus, in a sample of iodized salt by a redox titration using sodium thiosulfate. And I guess there might be starch involved with the iodine to affect a colour change. Student first reacts the iodate ion with excess iodide ions under acidic conditions to produce iodine, and the reaction is given below. Give the oxidation state of the iodine under each of the 3 iodine containing species. I'm not going to answer that, this video is about titration, so that's just an extra non-related question. The student dissolves some of the iodized salt in a small volume of dilute hydrochloric acid. The student then transfers the solution to a 250 centimetre cubed volumetric flask and makes up to the mark with distilled water. 25 centimetres of this solution is then centimetres cubed of this solution is then added to a conical flask containing a solution of excess iodide ions. The iodine produced is titrated with the standard solution of 0.001 moles per dm cubed sodium thiosulfate using starch. Thought it would. The reaction equation is given there. The student's results give a mean titer of 15.4 centimetres cubed. Calculate the amount in moles of iodate in the 25 centimetres cubed of iodate solution. So, strategies to cope with the sheer weight of information. So the first thing I'm going to suggest that you do, step 1, copy out those two equations next to each other. Okay, and then you need to underline key points in those equations. So what have I decided are the key points in the equation? Well, I've decided to underline IO3 minus in that equation. And the reason for that is clear when we look back. Oh yeah, look here. That's what we're trying to find the answer, IO3 minus. So that could be pretty important, so I've underlined it. Then I've gone and underlined 3I2 there and I2 there. Well, why have I underlined that? Well, if I have a look at the question carefully, it says here, iodine produced is titrated. Okay, so the student is basically carrying out this reaction with an unknown quantity of that's come from this unheard of sodium iodate. And he's produced some of that. But it's this that we're going to titrate. The iodine is going to be titrated, and it tells you what we're going to titrate it with sodium thiosulfate. Okay, so I've highlighted iodine because that's gone into titration. I've highlighted iodate because that's what the question's asking about. And I've highlighted sodium thiosulfate because that's also gone into the titration. Everything else in this question I can now forget about for now. All right, because it's just distracting. Okay, what am I going to do now? What's my next step? Well, what we're going to do next is draw out a titration table. Okay, we're also going to write down the equation that will be needed for titrations, which is always concentration equals moles over vols, or moles equals concentration times vols. So the table I'm going to ask you to draw is one like that. Okay, I'm going to ask you to put concentration, moles, and volume. Okay, and then in the first column, we're going to label what we can put in, what we do know from the question. We're going to search through the titration systematically. So let's read back from the beginning and see what we can put into this table. It says the student dissolves some of the iodized salt in a small volume of dilute hydrochloric acid. Well, that wasn't one of the things we underlined, so we're not going to worry about hydrochloric acid. You then transfer this to 250 centimetres volumetric flask and makes up to the mark with distilled water. That's not going to help us either. 25 of this solution is added to a flask containing a solution of excess iodide ions. So that's going to be the iodine. Okay, so we're going to put that into iodine in a moment. I'll read on. The iodine produced is titrated with the standard solution of 0.01 mole of sodium thiosulfate. Right, now we're talking. So I'm going to highlight that. That's going to be pretty important. And I'm going to put that down into my table. I've got 0.001 moles concentration. And then as I read on, it tells me the mean titer is 15.4. Now, when I put it in the table, I'm going to divide it by 1,000 to give the volume in dm cubed, and you must do that. I'm going to times 0.001 by 0.0154, according to the equation you see at the top there. All right, that will tell me the number of moles of sodium thiosulfate is going to be 1.54 times 10 to the minus 5. All right. So I know how many moles of that I've got. How many moles of that have I got? Okay. Well, what you have to look there is the mole ratio. When we look at the mole ratio, we can see that 2 moles of that react with 1 moles of that. Okay? And our unknown is 1 mole. Our known is 2 moles. So we're going to do 1 over 2 times 1.4 times 10 to the minus 5. So basically 0.5 times 1.54 times 10 to the minus 5 is going to give us 7.7 times 10 to the minus 6 there. You can see the answer appearing there, but just bear with me. How does that help us determine the iodate number of moles? Well, if we think back in the question, this was what was reacted first, and this was reacted secondly. Okay? This is so common for them to do this. So all of the iodine in here was produced here. The moles there and there are the same. Okay? Whatever amount of moles was produced there went into there. Okay? So now we have a known number of moles here and an unknown number of moles there. And look at the ratios. 1 mole of that reacts to form 3 moles of that. So we're going to put the unknown over the known, which is 1/3 times that. So we're going to do 1/3 times that. Okay, 1 divided by 3 times that gives us that, and that, folks, is the answer in terms of moles.